The far side of the moon, the half we never see from Earth, is actually one of the most scientifically valuable places in our solar system. At first, it's incredibly quiet because the moon blocks all the radio noise coming from Earth, making the far side the best spot nearby for radio astronomy. As scientists could place telescopes there to study faint signals from the early universe, things we simply can't detect from Earth. This NASA video shows a simulation of what the Artemis II astronauts might see during their flyby. And the far side of the moon looks very different from the near side. Fewer dark plains, far more craters, a thicker crust. And because it's so heavily cratered, the far side acts like a time capsule, preserving billions of years of impacts, offering key details in the record of the early solar system. And also, it's still largely unexplored. Most missions have focused on the near side because it's easier to communicate with Earth. On the far side, you need relay satellites just to stay in contact, which makes missions more complex and dangerous, but also pushes new space technology forward. Now, that hasn't stopped the world from paying attention. China has already landed missions there, and other space agencies are watching closely. Their strategic value, scientific opportunity, and the potential for resources that can support future lunar bases, including water ice. And that's where Artemis II matters. Now, this is the first time humans have flown this far, and every system of this spacecraft is being tested in deep space, far beyond the safety net of low Earth orbit. But the communication blackout alone, 40 minutes with no contact with Earth, is exactly the kind of challenge astronauts will face on the mission to Mars. This flight is meant to prove that humans can venture further and that the technology is able to support them.